extension. Good, but it's 7:30, so time to start. 7:30, at least here in Europe CET. I'm located in Belgium, so Sebastian Eggermont. Welcome to all. I'm just checking very quickly that things are working as expected on the Facebook page. Yes, that's the case. We have a few people watching, 4 at the moment. Hello, the guys on on Facebook. So the agenda for today, a bit less than usual. I think this period of the year, every time it's a bit more difficult to have people. I don't know why, if it's linked to holidays or something. But last year we tried to organize a hackathon as well in the Netherlands. It was really difficult to get people. I know there is holidays in different, at least in different countries in Europe, are starting more or less now. So maybe that's one of the factors here. But so we will start with Magnus, who's it's not the first time that he comes presenting a game written in BASIC V2 on the C64. When do you remember, Magnus? When was the first time you came?
It was in 2021.
21. Okay.
It was my Tetris.
Tetris game. Yeah, it's super nice. So took you three years to build this game then?
No, it took me 3 weeks. But meanwhile, I've also done a basic Pac-Man and a basic Space Invaders.
Yeah, the Space Invaders. I remember. I saw that you had shared it as well on different groups, if I remember well.
Yes, that's right.
Yeah. Then Travis, I don't know if I pronounced that correctly. Travis for TeensyROM.
Yep.
Yeah, perfect. Istvan with prototype replacement for the 8360 chip on the 264 series. I think that's very, very specific. That's not the kind of project that you hear about every day. That's super nice to have, of course, everyone in. Dave and Ken for this Rotor Rampage for the Commodore PET. That's nice. Active live action game or something like that, and that will be it for today, and then we will close by announcing when is the next meeting. Yeah. Even though there is no, after a few years, there is not really a surprise. We try to have these meetings every quarter. So just so that you know, so this is now live on Facebook, but it will also be recorded. So each of the talks will be recorded individually, and after we will make them available on our YouTube channel. And I will make the MP4 files also available to each of the speakers. So if you want to, I don't know, do whatever you want with it, put it on your own page or whatever, you can do so. Of course, we are in Europe, so there are rules, and in particular the GDPR. So this is being recorded, being streamed live as well. So people who would be in the call and who would not agree on being recorded, then just need to leave, unfortunately. That being said, I think I'm a bit in advance, but that's not bad, maybe. Knowing that sometimes we take more time than expected. So, Magnus, if you are ready, we can start with you.
I'm ready. Here we go. Hi, Magnus here, sending live from Sweden.
Yeah, just a second. I will stop sharing here. Let me go back. Okay, someone is waiting. I will also admit the people who are waiting now to join. Yes. And I will launch the recording as well. There it is, Magnus.
Shall I start?
Yes, floor is yours.
Hi, Magnus here, sending live to you from Sweden. I'm invited here this evening to introduce my latest game called Stranded. Stranded is an adventure game who is highly influenced by 2 of my favorite games all time, and it's Monkey Island and Day After Tentacle. Have you heard about them? I guess so. The plot is about a poor little fellow who got stranded on a deserted island in the mid-Pacific, and your mission is to bring him back home. The program is made on all in BASIC on the replica, the new 64, and I will take you to a guide through the game. 2 minutes. I'm just gonna zoom in a little better on the screen here. Here we see, okay, don't we? So now we are a little bit into the game where Jack, the main character, is about to post this message in the bottle and hoping for someone to come and help me, come to help him on the island. So I move over here to the ocean and I point at the bottle with the message. So I drop it here into the ocean, see what happened. Splash. It floats back, so I must find a better place to drop the bottle. So let's explore the island a little bit. Here's my stranded boat. Now we have a broken mast. And this is the message I wrote in the bottle, asking for someone to come and help me. My sail, and here's a fireplace I made earlier in the game to pull attention. And now we can walk to the next. Let's walk to the jungle. Here we got the jungle. There's a monkey. Shall we try to interact with him? We can look at him first. He's a dog-looking, stone-collecting monkey. Can we do with him? Can we talk to him? Hello there, monkey. How are you? Not too much to talk with. We get back to him later. Let's move on. This is the path to the cliffside. Now we've got a cave. And there's the cliff. So I shall try to drop the bottle from the cliff to see if that's better. So take the cursor, move it down to the bottom, and drop it. I think that was better. I hope it float away later with the tide. So while we're waiting for the tide, let's explore the island a little bit more. Move back here to the jungle. Move the cursor. Oh, the bottle is floating away. That's great. I hope someone will find it. Now we're back in the, oh, there's the monkey again with a pair of scissors. Weird. And if we walk through the jungle, we get to the other side of the island, the South Beach. Let's take a little look there. Now we got some stuff to interact with. There's a old shipwreck in the background. We got a palm tree with coconuts, I think. Coconuts, yes, we can take a look. That's food supply for a week. That's great to know. And here we have a parrot. Parrot sitting on a mast. That will be perfect because my mast is totally broken, so I need a new one. So I try to pick it up. I don't dare, the parrot might bite me. So some way we got to move the parrot so I can take the mast. But there are puzzles that you have to solve to complete the game. But now let's go back to my stranded boat. Then I will talk a little bit about the code. Back in the jungle. So in each room, I use a different loop just to speed it up a little bit. There are 4 loops in the game. I was mistaken it was just a beast party. Bad luck. I had to do something more to call the attention. But that's up to you when you play the game to figure out. Now I'm going to talk a little bit about the code. use this one variable telling the computer where we are, the trash sale, and when I move the pointer, another variable telling what we're looking at. So the thing I use is the P command. The P command read the first two letters in the word. So peak on that spot makes an A, and then on the second peak is an X, and then must be the word X. An X, I name it a number. The X is number 11. So I'll break the game here so we can take a little bit look at the code. So this is where PP is the peak for those spots. And if PP is A, which is 1, and the second letter is 24, which is X, then the item number is 11. So then I know what I'm interacting with. And if you look at the code here, the code is very, very long. It took me about 50 hours to write this game. And I like to send some thanks to Fredrik Romsberg, who helped me out when I got stuck in my own code, because it happened a few times. And if you like to download and play this game, you can find it in the file selection of the Facebook group Commodore 64/178 and some other places too. There you also can find a link to a compiled version made by the Genesis project. You can also even find a download to a Mega 65 version of the game, because Gurke from Sydney has made a great job struggling through my messy code to convert it for the Mega 65. And he even added sound and music to it, good music. And the game is also a little speed up there. So as an anchor, I will show you a clip from the Mega 65 version of the game. So I'm just gonna take the camera here. Go over to my PC.
With that dance, it looks like Staying Alive, doesn't it, with John Travolta? Maybe that's a good name.
So, and I also tried to put the links to where you can download the game, and please do that because he spends many hours making it. Try to put some link into the comments or something. But I think that's all for me now. So if you don't have any questions, have you?
Great, many thanks.
Ready for today?
I have actually a couple of questions. First of all, it looks faster on the Mega 65, right?
Sorry, it's because...
Can you hear me?
Oh, not too good.
Magnus? No?
I can hear a little bit, so if you speak...
Okay. No, I was just noticing, I had the feeling it goes much faster on the Mega 65, but...
Yes, 10 times faster, at least.
Okay. Yeah. But it's not. It's just the execution from the system. It's not like the code was changed to make it faster, right?
I think Igor can make spend a lot of time to speed it up to, I don't know how it works, but he speed it up some way and have to manually change a lot in the code to make it work. And it also is a compiled basic version, and not basic, and compiled version where you can run on a C64.
Okay, no good.
So the links are somewhere out there on the Facebook group, but maybe we can add them later to the comments.
Yeah, that would be nice, definitely. Now I see you showed the code there on the. I guess that's the C64. Did you use any tool like an editor, an IDE, any existing libraries, or did you?
No, the only tool I use is my own homemade sprite editor to write the sprites. So that's the only tool I have been using. Otherwise, it was a lot of work. So even to write to do the sprites, I have to use the data 255.0. It took a long time to make the sprites, but here we are now. But ready.
Okay, so it was all typed into the C64. Really,
all made on the C64. Yeah, that's my
school.
best investment I ever done. I think. I have a lot of fun with that machine.
Super nice. Good. Okay, I don't know if there is any other questions.
How many lines of code is that there?
Oh, I don't really know, but must be hundreds.
Looks into
I think the game is about 122 bytes on the floppy disk, so it's quite big. And the sprite comes in a separate file because you first load a loader and then you load the sprites, and that's another 12 bytes something. So I haven't counted lines, but it must be hundreds.
I think that's how we all learned to type in the 80s, wasn't it? Writing basic programs. Sorry? That's how we all learned to type, wasn't it? In the 80s?
Right, yeah. That's how we learned to type my machine. Because in school, I was the best in the whole class to use a typewriter. I learned that from the C64. I was even faster than my teacher with the typewriting machine. So any more questions?
How many rooms are there in the game?
It's not so many. It's actually it's only 4 rooms. So it's right. It's not a big. It's not Monkey Island big. It's pretty small. But
so you'll have version game pack 2 out soon then with another 4 rooms.
There could be an extension set, yes, with more rooms
on
another island.
The first is free, and then you pay for the extensions.
The extension costs a lot of money, $12.
I think you'll need to buy in some Commodore 64 keyboards, just in case.
Just in case. Actually, I got 2 of this machine because I'm afraid they were running out of stock. I don't think they will make more. So I found another one at the electro shop here. So I bought a second one just as a backup if this one got broken someday.
Gotta have a backup.
Yeah.
It's good to have a backup. Not bad at all. Okay.
Good.
Excellent.
Any other question? Worst case, you can still type it in the chat, I guess, and Magnus can read them from there. Many thanks, Magnus. I will stop the recording now.
Yeah, thank you very much.
And then you can stop sharing, and then I can invite Travis to start sharing his screen. Yes, just wait a second, Travis. I will also launch the recording here. And the floor is yours, Travis.
All right. Thanks, Sebastian. Yeah, my name is Travis Smith. I'm here to talk to you about the TeensyROM interface and fast load and emulation cartridge for the 64 and 128. The background story is the same I hear from many of us. A youngster started using the PET, then VIC-20, then C64, but once I moved out of the house, I left that behind to pursue a career in high tech, and finally got retired a couple years ago and got back into it. And now I'm kind of trying to combine those two past histories into one. What it is, I'll talk about in quite a bit here. But why did I make it? I wanted to do an open source project for one, to kind of give back to the community that is ever sharing these types of things. And I didn't see any cartridges based on the Teensy 4.1 and wanted to take advantage of its high processing speed and external interfaces. And there's a large library of support to make development go quite a bit faster. Started as an experiment just to do ROM emulation and got that going, and realized I could keep going from there. This is what it looks like. The expansion port connector on the back here. There's 2 USB connectors to connect upstream to a computer, or downstream, or vice versa, to a USB keyboard, for example. And a RJ45 jack for Ethernet and an SD card slot. So the features here are, the basics are, does ROM emulation, so all the generic single ROMs as well as multi-ROM games. Ben Squibb has done a great job of putting the one-load collection together, which is a great way to enjoy these kinds of cartridges. And the fast load capability, there's a little bit of a demo here. Takes about 2 seconds to load a 48K program. It actually takes a little longer to decompress after it's loaded than it does to load it itself. And you can load programs from a micro SD card, a USB thumb drive, and there's also about 60 programs that come built into the flash. There's a SID player that adjusts the tempo based on the machine type and the SID requirement itself, and a picture viewer that'll view koala multicolor as well as standard high-res pictures as well. So what you see there is real-time loading and displaying pictures. The MIDI interfaces, I should say, emulate the standard MIDI historical devices. The 2 methods are connecting through USB-A and USB-B types. So with the A type, you can connect a USB MIDI keyboard and play software such as SynthCart and Station 64, and there's a few others out there. You can also use your C64 to play out into your sound-capable device if you want to do something like that. The USB-B connection connect to a computer where you can stream out MIDI files or use a sequencer to stream out MIDI information ultimately to your SID chip. Or you can use programs such as DeepSID, or website that is, to use the ACID MIDI protocol, which you may not be familiar with. It embeds SID data into the MIDI stream. And there's one program out there called Station 64 that can actually interpret that data and play it back. So you can actually stream SID files over the internet through your computer into your C64. The Ethernet interface simulates a SwiftLink cartridge with a modem connected. There's AT commands to set up the Ethernet settings. So you can do the standard telnet type of BBS connections there's still several of those out and about. You can set your C64 system time. You can sync that to the internet. If you don't like the hardwired, there's Ethernet to Wi-Fi bridges out there you can use if you would rather go wireless. There's a text-based web browser feature that I'm pretty proud of. It can filter complex sites into text, so it is text-based only for the most part. There's a search engine link in there, so you can do internet searches. There's a custom HTML tag to display PETSCI type graphic characters, which is what you're seeing on the right here is my demo web page, which has PETSCI graphics built into that. When you download something from HTML, it'll download it directly to the USB or SD card. So you don't have to wait for the bottleneck of the 64 itself to do downloads. And then you can launch those files right from the browser. There's a bookmark feature, so you can, when you find websites that you enjoy, you can save those, and those get saved in the local EEPROM. And there's also a site browsing queue, so you can go back to previously visited sites fairly quickly. There's a couple alternate interfaces developed. This one is developed by William Pereira that runs on a desktop system, and you can fully control your C64 from a desktop computer. So you can immediately launch games, SIDs, or any other programs remotely by looking at the SD and USB drive and launch those. It's got some search features, so you can quickly find things in some of the large collections that are out there these days. You can flag favorites and quickly go back to those. There's a pretty cool SID playback capability from there that keeps track of time through the database. So you can do sequential SID playback, playlist type of thing. And there's a pretty cool random feature where you can play random SIDs. Since there's about 50,000 SIDs out there, it's kind of nice to just hear them randomly, and you never know what you're going to hear there. You can transfer files from your desktop to the SD or USB card with a drag and drop feature that has recursive functionality to take full directories and subdirectories of files in one swath. He's incorporated a lot of great meta data from the high voltage sync collection, the deep SID and OneLoad64. So you can see it in the screen chapters over here. This SID view shows you, if assuming it's available, the composer and information about them. And for games from the OneLoad64 collection, shows you splash screens, etc. as a preview. We recently introduced an NFC launch system. Start that going here. This was a co-development between myself and Ben Squibb, also known as StatMat of OneLoad64 fame. He knew about the TAP2 project, which kind of pioneered this methodology. And we actually share a lot of hardware with that project. We support some of the same scanners. There's 3D case designs that are compatible to both. And the NFC tags themselves have a graphics interface so you can quickly print your own tags. So it kind of gives the physicality of old school cartridge loading with the fast loading times of modern computers. Next. Okay, a little on the technical side here. The prototyping started in December of 2022 in this rat's nest you can see on the upper right here. But that was enough to get me going to do emulation and know that if I laid out a PCB, it would work. So the first board was taped out a little over a year ago. The core architecture has remained the same since then. So the software compatibility has remained the same. The slight board changes have just been cosmetic and to accommodate 3D printed cases, etc. The hardware design was taking makers and hobbyists into account so that hopefully people feel inclined to build one themselves. It does have SMT packages, but they're the larger types, so 805s and SOICs that are a little easier to solder than some of the real fine pitch stuff. Two-sided SMT to keep the board size to a minimum. And there's a BOM published with links to DigiKey for all the parts. You can do a big shopping cart and buy all the parts at once. And it takes about an hour to assemble and test one. Block diagram, so the Teensy has an ARM Cortex processor in it, a 32-bit processor that it's all 3.3 volt levels, so most of the external logic is just voltage translation between that 3.3 volt and the 5 volt of the C64 128. It's mostly straight through level translation, just a little bit of extra logic here for the read-write line, but other than that, it's mostly a software-defined architecture, which makes it fairly flexible in that aspect. On the software side, the Teensy is all C and C++ code. It all compiles in the Arduino environment, or I should say Arduino and TeensyDuino is the add-on for Arduino to to enable some of the features of it as well. All publicly available libraries. So it's fairly straightforward to compile and modify. Excuse me again. The expansion port timing control is probably the trickier part of the implementation. Basically, there's a high priority hardware interrupt that triggers on every rising edge of the V2 clock. So about once every microsecond, a hardware interrupt is triggered, and that starts a timer to know when to read or write key signals to execute reads or writes to and from the 64. So because it's an 816 megahertz core in the Teensy, I get almost 1 nanosecond of granularity, which is a pretty good timing control for that interface. So it spends anywhere from 150 to 900 nanoseconds within that routine out of every microsecond or so. 150 is if the transaction, it takes about that long to determine that the transaction's not for the Teensy and can go about its business, up to about 500 nanoseconds for a standard read or write, and up to 900 nanoseconds if it's a full VIC cycle emulation, which there's only a few games out there that actually require that, but it is supported and emulated. IO handlers are done via a common struct definition with pointers to each one that get indexed and pointed to depending on which handlers are needed. Those structs define entry points for specific routines to handle depending on what's required, an IO 1 or 2 transaction, a standard read-write, etc. And then there's also a polling functionality for background types of tasks. Teensy memory was a bit interesting to try to manage. This map on the side shows that there's basically 3 memory types of memory segments. There's 2 RAM segments of 512K each and 1 large flash of 8 megabytes. Not to scale here, of course, but it gives you the general idea. The tricky part is that only the RAM has a fast enough latency to do that ROM emulation. I can't emulate directly out of flash because the 400 nanosecond access time that it takes is just a little bit too slow for emulation there. So whenever I'm emulating something, that gets copied into both the RAM banks, and in the case of a very large multi-chip emulation. And then in the flash itself, we can force execution to happen right out of flash for lower priority routines. But then normal, faster execution times can be achieved by having that code reside and executing right out of RAM. The firmware can be updated, it can be self-updated, I should say. You can copy the hex file right to the SD or USB card and have it execute and self-update the flash. There are a couple of pads available for external RAM or flash on the Teensy itself, but those have that same QSPI interface that the local flash has, so I haven't found a good need or use for that yet. On the C64 side, it was all done in 6510 assembly using the Acme compiler. It's currently a little less than 5K in size. The way it works is it boots emulating a standard single chip 8K ROM. And the first thing it does is copy that information down to the 6000 range of RAM inside of the C64 and passes execution to that, and then disappears or vanishes the original ROM. So it's not taking up that chunk of memory anymore. That's to allow for self-modification code and also to stay out of the way of most SIDs when they're playing. For most of the time, the C64 code is the master in that it makes requests to the Teensy when something is needed. And that's done through a common register set defined in the IO1 space. There's about 32 registers defined, depending on what's needed, whether it's to go execute a program, start or stop a SID, etc. And of course, that definition is shared in both the assembly code and the C code so that they're both speaking the same language, so to speak. And then the register, the fast load capability is done by a single register. The C64 code reads that register repeatedly, the same location, and the Teensy side is fast enough to know that that read has happened, updates the value so that the next read that happens in the next clock cycle can read that same location and get the next value. So it makes the fast load fairly quick in that aspect. So although most of the tasks are originated from the C64 side, there is an interrupt driven from the Teensy side for Teensy initiated actions, most of which is the remote launch capability used by those remote interfaces that I talked about previously. There's quite the list of potential improvements or additions in the future. The USB host interface gives lots of options for, been talking about Bluetooth interface or adding a printer to that, or a keyboard or mouse. There's lots of other types of files that I'd like to support. There's some improvements that can be made on the SID player and browser, et cetera, et cetera. And I'm also keeping a list of potential hardware improvements. I don't know when I'll get to a future design. I'll probably wait for the next generation of microcontroller to look at this, but this would give us some other new and nifty capabilities. So you can, here's a list of links. You can find all the documentation, design files, source code, firmware releases, and the 3D printed case files are all on the GitHub site. There's a great Discord server with lots of like-minded folks talking about the TeensyROM that gotten some great input from there. I try to do a demo video anytime a new feature is added, and there's a big playlist available there. And if you're not up for building your own, I sell them myself out of the Tindy shop, and there's a couple other shops out there that sell pre-assembled and tested units as well. So thank you to these people and a whole lot more who have helped and contributed and given ideas for this project. Something I certainly could have done alone. I couldn't have done alone, so I certainly appreciate that. That's about it. Questions?
Yeah, questions? Time for questions, I guess.
I want one.
I can say, yeah.
Yeah, I think it's incredible. It's something I've been thinking about a long time, that it should be out there, but it's there now. So brilliant.
It's a particular feature catch your eye, or?
Well, I mean, I don't want to drive too technical, but how does it sort of suspend the CPU running and while it replaces stuff in the working memory, or how would you?
No, it actually doesn't do true DMAs. I've been able to do this all without a true DMA functionality, although that's something I would like to look at in the future. But no, the transfer, the fast transfer capability is all done through that single register read I spoke about shortly earlier, and that the assembly code reads one register, one IO space register over and over, and copies that into the local RAM. So it's able to get basically 1 byte every microsecond by reading that over and over. And of course, the CRT emulation itself is done by emulating a ROM, so there's no actual transfer to RAM needed. It's all emulating an external ROM as like a ROM cartridge would.
All right. Sweet.
I see a comment from William Pereira. Amazing work, Travis. So I guess it's the same William Pereira that you're.
It is.
Probability.
I will.
Good. I have a couple of questions as well. So it comes back with a few software there. So you've been showing the browser, these things. How can one maintain this one? So, for example, if there is a bug somewhere in one of the software that comes with it, how do you? Is it all from your GitHub, or do I need to take one thing here, one thing there? How does that work? Do you have
Everything is available on the GitHub. So when you install the Arduino environment and the Teensy, it's called TeensyDuino environment, which is a layer on top of Arduino, that gets you 99% of everything. There's one library just added recently for the NFC capability that you do have to download to support the scanner, the NFC scanner. But other than that, all the libraries come standard with the Arduino environment. There's a build page I created in the GitHub that shows how to, or where to find all those utilities and how to install and build it yourself if you want to do it that way. Well, that's the Arduino side. If you want to compile the assembly side, of course, you'd have to download the Acme compiler and run a batch file to do that if you want to get into that low level of detail. But most things can be, most people who want to tweak the code themselves are able to do things in the Arduino level on the Teensy side.
Okay. Yeah, good that you mentioned a website as well to purchase it from Europe, because it was my first, when I saw ships from USA, then usually it gets at least in Belgium, most probably it will get taken by the customs, and then
yeah, I see those. I get a lot of orders from Europe, especially since Ben Squibb's been involved in that last project. It's become pretty popular over there, and when I send them out, I see the landing costs of all of them, and I know I've actually talked to a couple people over there about potentially building them and selling them locally. So hopefully it'll bring the shipping costs down. So.
Yeah. Good. And then you have good plans for the future. You plan to do all these things by yourself, or are you welcoming? I don't know,
yeah, I definitely welcome feedback and input. The first truly collaborative was the NFC capability, in which I worked with Ben on some of the low-level stuff. William has done the user interface pretty much on his own with some feedback from others, and I get lots of feedback as far as ideas, and I certainly welcome code input, but so far it's been mostly me doing the actual coding itself, which is fine. But yeah, there's GitHub supports pull requests and the whole methodology. I'm certainly open to that.
Okay. I see a question on Facebook from Gertz, actually. He's asking if the cartridge will work on the Mega 65.
That's a good question. I believe so. There's been a lot of compatibility testing, but I don't have my list in front of me right now. But basically, as long as the expander port is running at the same timing, I know it's been tested on many of the newer FPGA-based types of C64 emulators. So as long as it has a expansion port that's compatible with the C64, it should. And I'm I hate to say it definitively, but I'm pretty sure that the 65 has been tested as well.
Maybe that's a mission for Gerse. That's your way to contribute, Gerse. You can buy one and then you can try and provide feedback.
Yeah, I appreciate all feedback.
Good. Any more questions from the attendees? Apparently not. So many thanks, Travis.
Thank you.
Now.
I think I can do that.
And then I can ask you to stop sharing.
Stop sharing, yeah. I had a problem figuring out how to do that.
For me, it's at the bottom of the screen, but with the rich client, it can be at the top.
Darn it, just stop.
But otherwise, if each time you start sharing, normally it should take over the session. Yes.
Okay.
Let's try that.
End slideshow. Did that do it?
Yes.
Okay. Sorry about that.
And no, it's still there is a slideshow that you just stopped.
Darn
because
it.
Yeah.
Stop. Can you override me? And
yeah, Istvan, can you try sharing?
When I try, it says you cannot start screen share by.
Okay.
oh no! Now I've done it.
Why you only? What do you have down there where this share screen button is? What can you see there?
Let me see.
Yeah, it's not.
Okay, I can stop your sharing.
Okay, thank you.
I forgot for a minute that I was the admin.
Thank you.
Good. So Istvan, normally you should be able to.
Yeah, I'm sharing then my slide.
Yes, perfect. Just wait a second. I will start the recording. In the meantime, you can do full screen or something. Yes, Istvan, the floor is yours. Thank you.
Okay, hi everyone. My name is Istvan Hegedus from Hungary, and I came here today with a project that I've been working for very long now. This is called FPGATED, which is the re-implementation of the TED chip of the Commodore 264 series computers, which is, as you can see, the Commodore 16, 116 and +4. About myself, I'm living in Hungary, Budapest, and I have an MSc degree in information technology. And I'm a network design engineer working for an international company. And when I was a child in '85, I got my Commodore +4, and I loved it. I loved to program it in assembly because it had the built-in TED monitor. So I always wanted to be an IT guy, an engineer, computer engineer. The only problem was that I never had a floppy drive for this +4. I always used tape drive, which made it a little bit difficult to program, but later I managed to get the drive when it was already obsolete, but I have floppy, of course. So my interest started at the university in FPGAs and digital computer architectures, and that's how I started this project, the FPGATED. The main goal objective of this project is to create a cycle exact FPGA replacement for the MOS 8360 chip, which is the graphic chip of these computers. And it should work in all 264 series machines by replacing only the TED chip. So the idea was that I just remove the TED chip and replace it with this new chip, FPGA, and all the others like the CPU and the other integrated circuits in the machine will stay and work as it should. The solution should be not much wider and longer than the original because it must fit in the case and on the motherboard. And all its pins should function fully. I mean here the analog connections also, because the TED chip has analog chroma and luma pins, so they should also work. And of course the audio, although that's digital. So due to this, it should provide a picture via the original RF modulator, via the RF cable or the video connector. And of course, its price, my main goal was that its price should be reasonable, because still you can buy the TED chips, although they are more and more expensive now every day. But it should be reasonable. Some history. So how I started one day my Commodore +4 did not turn on, and I suspected it's the TED chip. And this is how the idea was born, that if I cannot purchase a new TED chip, then it would be great to replace it with an FPGA solution. Spoiler, the problem was not with the TED chip, but it kicked in this project, so I started to work on it. And first thing when we start a project like this is to investigate the internet, check the internet whether anyone has done it. And I was surprised that no one. I found the FPGA 64 project, which was interesting, and I learned a lot from this. And that's when I decided that I will create one for the TED also. I started with the Xilinx FPGAs because I knew them from the university, and used Verilog HDL instead of VHDL because I found it much more close to C language, and I could program it in C language, and I like C language. So for me, Verilog was the best choice. So how to start a development like this? First of all, extensive information research on TED. Here are some resources that I used, like documents available on the internet, the hardware specification book, the TED preliminary datasheet. It was very useful. And even the TED patent I have found on the net, which describes some of the inner workings of the TED. I do believe it's not fully the implemented chip, but it helped to understand some aspects of the chip. As you know, in Hungary, these kind of computers were very, very popular in the 80s and the beginning of the 90s. So it has a huge base of programmers. So I investigated these forums, searched these Hungarian programmer forums where they discussed all the internals and tricks of this computer, which was very useful. I collected out lots of comments and messages. I have a doc file collection of those from these programmers. I have done measurements on the real hardware also, used the Open Bench Logic Sniffer, which is a very cheap solution. And for this, it was just enough with 16 channels. And luckily, I have an oscilloscope, so I could done oscilloscope measurements also later. In addition, I have analyzed emulator codes. It is also very useful, and I managed to contact Bill Hurd too via the c128.com page, and ask him also about some inner workings. There was one Hungarian guy who helped a lot with the audio part, because I had no idea how the audio generator works and how could I implement it. And Levente Harsányi, he explained it so well with digital integrated circuits that I just had to write the code and it was working brilliant. So it was really a great help. So let's see how I started the development. I did not use that breadboard where I use the cables and connect components. I started with this Papilio 1 and later Papilio Pro FPGA development board, which you cannot see here. It's the board under the green one, the red board. And I created this TED wing for it, which has, as you can see, DRAM chip connections with a voltage level translator here in the middle. It has a VGA connector with a resistor network doing the digital to analog conversion. Of course, I needed to test it with software, so I decided to add the IEC bus connector. The idea came from the SD2 IEC project. I investigated that one too, so I managed to add it. And the PS2 keyboard RS232, although I never implemented the RS232 part, maybe one day. Then I started to write the code, the core in Verilog in 2015. I know it's long ago, almost 10 years ago, but really I started so long ago. And in 2016, end of March, it was already working in a way. Here on the screen, you can see that the first time I've seen a picture, it was garbage, but I managed to fix that. And by June 2016, the first public release was ready, and I shared it in Hackaday. This was advised to me by Bill Hurd. He told me to use Hackaday for this project. And although it was still not a drop-in replacement, it was very useful and I liked it. I like to use it. On this picture, you can see a C64 also. And there is the Open Bench logic sniffer analyzer on it. Those cables are there. So it's not working. The prototype is working there. Later, I started to develop further a +4 core in it with the Papilio Pro's DRAM. So I had to write a DRAM controller. I used the SPI flash for multiple kernel and basic ROMs, which are switchable. But this took a little bit too long time for me. So that's why the delay in the final product that I created. So let's see the drop-in replacement, because this is much more interesting. Here we can see the first version, which was a proof of concept from myself that it can work really in a real C64. And because I had to do the hand soldering, I've chosen a 2-layered PCB board with the Spartan 60 QFP 144, because this one you can easily solder. The size of the resistors and capacitors are 805. So easily manageable, but still it's better to solder it under microscope. But I have hand soldered it completely. In this one, I have implemented CVBS, which is the chroma and luma signals, the analog chroma and luma signals. So when I installed it, yeah, you can see here the different parts. When I installed it, that time the RF modulator was already working. Now you can see here the components, not too many components. I did not want to make it too expensive, so I wanted to make it with as few components as possible. There is of course, the heart is the Spartan 6 FPGA, which is already today obsolete because Xilinx has moved to Spartan 7. There are bus switches with which I do the voltage level translation to 5 volts, between 5 volts and 3.3 volts. Luckily, not all signals need to be translated, because outputs, which are inputs from the motherboard point of view, they can stay on 3.3 low LVTTL level. So I just needed to translate the data bus the keyboard lines, and some signals. I don't remember by heart, but IRQ probably, and some other signals. There is an SPI flash on it, which contains the code of the Spartan 6, but it has plenty of room for additional data storage. So I plan to use it to store kernel ROMs also. From the beginning, my idea was that I want to see RGB picture also via SCART RGB connection, sRGB. So I plan to add this VGA RGBS header, and by default it works with 15 kilohertz RGB. So if we connect it to a TV or a monitor with a SCART, then we can have an RGB connection and very sharp picture, much better quality than the original via the chroma and luma signals. Here is a photo how it looks like inside. It's still wide compared to the original integrated circuit. One thing I did not mention, the connection underneath. It's an SMD DIL connector, IC connector. Later, there will be a picture of it. I was afraid a little bit of it because it's not a cheap piece. But due to the size, I could not solve it with a through-hole IC socket. And this gave me a freedom on the top side, on the top signal layer. The next thing was to develop it even further, because I knew that the TQFP is not a solution and a two-layer board. And the main idea was that we need a 4 layers PCB where the top layer is the signal, inner layer is power and ground, and there is another signal layer on the bottom. I used here a BGA chip to have it even smaller, which is the Spartan 6 LX9 CSG225. And on this one, we still have the bus switches. In the meantime, one of the bus switch got obsolete also, so I had to replace it with another one, but luckily these are not difficult to replace with other vendors. And I decided to include HDMI because the Spartan 6 can support HDMI. It has a TMDS signal output, so why not to use it? And when I designed this board and built it, the HDMI part was not yet working. It was just a plan that in the future it will work. Due to this, I had to move the VGA RGBS header on the side. So the space on this board is heavily used, as you can see. It got slimmer, but a little bit longer than the original version 1.0. But it looks much better inside the PC, inside the motherboard, in the case. On this one has on the HDMI these resolutions, 720 times 576/50 Hertz, or if we use it in NTSC mode, then the 48/60. And we have digital audio out on HDMI. This was important also, that if I want to connect it to a TV via HDMI, I want to get the sound via the same cable. Let's see the backside, which I mentioned. So this is that SMD IC socket. I put here the type. You can buy it on Mauser. It's Presidip. As you can see from the photo, it has the straight legs, and on the top they are bent. 90 degree, so I can solder it on the PCB. And it works really fine. One problem was that the C16, Commodore 16, has a very bad quality of integrated circuit socket for the TED. So that must be replaced because it's so bad quality you can hardly insert it. You can, but it's very difficult to insert. You need power, strong power to insert it. Then COVID came and the chip shortage came, and Xilinx has stopped the Spartan 6 just when I wanted to start the production, mass production. So a couple of years went again. I don't know how familiar you are with it, but during COVID and after COVID, it was almost impossible to purchase FPGAs. So I could not purchase the Spartan 7 or Spartan 6. Thus, I had to wait a little bit, and I could start to produce this version 3.0 in 2023. Although in the meantime, I was working on the code to move it to Spartan 7 because it's a little bit different than Spartan 6. There are, however, better solutions inside. The HDMI part is even easier to code. So I was ready with the code, but I did not have hardware. But by the end of 2023, November, I managed to get Spartan 7 ICs and got the board planned in Eagle, and I had it produced by JIC PCB. They produced it, but I had to hand solder it. And I did not mention that with the previous version also. I have done all these solderings are hand soldered. I bought infra heater so I can solder BGA chips. And surprisingly, it is working really fine and quite easy to solder. A lot of people are afraid of BGA soldering, but it was working for the first time. What do we have here? A little bit improvement was that for HDMI, I have included the ESD protection. Here you can see that we have ESD diodes, and also for the VGA connector, ESD diodes. But all the others are mainly the same. Spartan 7 needed one more LDO because it needs 2 core voltages. But otherwise, it's the same. It uses less power. Here it is how it looks like inside the C16. I use the C16. I have the +4 also, of course. But I use the C16 because there is plenty of room inside, so you can easily connect. And here on the photo, you can see that I have the HDMI connection and also the VGA connector. I have with this cable, I created an adapter for it. The JTAG is not needed in the final product. This is for me to program them. So let's see, the summary of the main feature. I don't want to go into deep details how it works inside because we don't have time for that, but you can read it on Hackaday, some specs. So what the final product or current version 3.0 is using is this Xilinx XC7S15 CSGA, and it has below 50% utilization, so there are plenty of room to add new features, and I'm planning to add more features. CVBS chroma and luma output to get picture by RF modulator. Chroma is created via direct digital synthesis, if any one of you know what that means. Luma creation is at the moment a secret. I don't want to reveal it because this was the most difficult part of it, because you can imagine that an FPGA, maximum voltage an FPGA can produce is 3.3 volts, and the Luma must go above 4 volts. So here I have a trick which later I will reveal, but not at the moment, because first I want to come out and make it available for others. And then later it will be released to public. RGB header is there still with switchable, software switchable between 15 kilohertz sRGB or 31 kilohertz VGA. Actually, it's 30 kilohertz. HDMI connector, the same as with the previous version. Digital audio output, and it works on flat TVs, and software switchable scanline effect I have added, because on the flat screens, for someone maybe it looks a bit weird that it's too sharp. So with the scan doubler, built-in scan doubler, I could create the scanline effects. And in addition, I created 4 software selectable color translation tables for HDMI and VGA output or sRGB. Not for the Chroma Luma, those are built in, but these ones, we can, via registers, we can switch them. And one of them is a custom color table that will be modifiable via registers. The flash, SPI flash, is accessible from the +4 side, so in the future, firmware upgrades are possible from the +4 or C16. So here is a photo, how it looks like on my Dell monitor, EFT, without scan lines, so it's quite sharp, as you can see. What are the future plans? Of course, my first priority is to start creating in batches production for sale. I need to investigate. I don't want to solder it myself because it's time consuming and difficult, but I want the JSC PCB to produce them or other companies, so I'm currently seeking for that. SID chip development should be easy. But so far I had no time to deal with it, but it should be easy to add a SID chip inside it. So having a SID card. Improving the TED core, although it's, I would say, 99% accurate. I have seen some glitches in some of the demos, very rare, which still I want to take a look and fix. The FPGATED configuration software I am currently developing, this will make it available to modify the registers, save the configuration to the SPI flash, so when we turn on, it will load it. And of course, the custom color table also. Thinking on some kind of copy protection in hardware, because I would like to avoid that Chinese people copy it and sell it. I want to use the SPI flash for additional kernel basic ROMs. Although there is no RAM on it, there is some RAM, DRAM, no, static RAM inside the FPGA still. So I'm planning to use that. Here are some references where you can get more information on this project. Hackaday.io, this is the main page where I'm sharing always the progress, and the core is shared. The very low code of the TED chip is shared, so that is usable. But of course, you cannot use that to a drop-in replacement without some additional codes. GitHub TED core, yeah, I put it to GitHub. You can find it there. +4 implementation. This is if you have a Papilio Pro, you can build a TED wing and you can have a +4. And I know that the MIST FPGA team, they have used this core. So if you have a MIST FPGA, you meet with it. That is also based on my core. So that's it about the presentation. I don't know how much time I have. Do I have?
Let's go for some questions. Yes, Istvan, don't worry. Many thanks actually for the presentation. I was laughing when you mentioned during the COVID period that the FPGA was impossible to find. I think because why was that? Because everyone was doing the same actually, nothing to do at home. So
Yeah,
so no, but there is a question in the chat actually from Francois. I think it relates to not to the drop-in, but to the first prototype, if I'm correct. And he's asking, on the Papilio, the FPGA emulates both TED and the rest of the machine. Is that for testing?
Sorry, I did not get. Sorry, can you repeat the question?
I will just read from the chat. So on the Papilio, the FPGA emulates both TED, TED, and the rest of the machine for testing, question mark. Or maybe you can formulate your question if you like.
Oh, sorry, I'm trying to find it in the chat, you said.
In the chat, yes.
Yeah, exactly. So it's not, of course, it's not just the core, because if there is the core only, the Verilog code of the core, that's only the TED chip, and the C16 has the CPU, it has other supporting chips, the PLA. So yes, the Papilio core has a 6502 core also. It was not written by me. I used the T65, and the PLA is very simple. So I added that, and there is the wrapping around it. So yes, the Papilio Pro has a C16, Commodore 16 inside, not the +4. But if you want the +4, then on GitHub you can find, because I have written that one too, the +4 core. So yes, it has more inside. But this chip, the drop-in replacement, has only the TED part, and all the logic that needs for it to connect it to the motherboard and talk to the other integrated circuits on the motherboard.
Okay, thank you. By the way, the version 2 and 3, they look so neat. I mean, the design is super nice when you show that.
Yeah, I wanted to, if I switch to my phone, I can show you. Let's see. Can you see my screen?
Yes.
So I'm using now my phone. Here is my desk, and you can see that here is the C16 with the chip connected. I have the analog connection to a VGA connector here. I connected the VGA here to the Dell display and the HDMI also. Let's turn it on. This is now the digital display with the scanline effects. So the signal comes via HDMI and via registers. I can switch it. I have to cheat a little bit, because if I want to switch it to VGA, then I have to put 01 here to this register. I turned off scanline effect, and in the monitor, in the display, if I switch the input to VGA, and let's see, we should see, yeah, this is the analog VGA display. It's also good quality but the HDMI is much better, of course. And if we want scanline effects here, then we have to type 03 here. And on the VGA, we have the scanline effect. I don't know whether you can see it on the screen. But
yeah, we can see. Yeah. Thank you.
And at the same time, if I turn on my old CRT, the analog connection is there. So what you can see here is the CVBS signal, the chroma luma. So at the same time, they can work together.
Nice. Okay. I see Travis has a question as well on the...
I do. First of all, it's a great project. I've got a +4 with a bad TED, so I'll be your customer here. My question was about the joystick interface. I know a common failure mode on the TEDs is the latch on the joystick interface. Did that come out in your development, and why that's been a common failure mode?
Yeah, that is actually the keyboard latch, which used to die in the original TED chip. And that renders not the keyboard, but the joystick interface to not operate. And that one is not, this chip is not affected by that one. The inner problem with that latch is well described on the +4 forums. In the +4 word forum, the guys, they have identified what is causing it, but it's mainly inside the MOS chip, a transistor in the latch.
Like a race condition of some kind? Or?
Yeah, actually, well, it dies because of the ESD. So I cannot explain now the exact problem, but this one, the TED is not affected. Well, I mean, this FPGA TED is not affected by that, definitely.
Great. Thank you.
Although I have not added ESD protection on those lines because those are coming out via diodes from the motherboard, but it's much more safe than the original one. Yeah.
So it's more ESD damage than a design limitation.
Yes.
In the originals, of course. Yeah.
Yes, and okay. One comment regarding the HDMI audio is going via the cable also. Of course, not on this display. That display doesn't have a speaker, but I have here a TV screen. I can show it there also. I don't know how much time do we have. Do we have time, or probably not, right?
We are
yeah.
Well late.
So I don't show it now, but on that TV, the audio part is working also quite well.
Like a quarry for the +4.
I had some challenges with the HDMI audio, and it's because of the audio was by nature digital, which is coming out of the TED, and I had to sample it, you know. But normally when you sample an audio signal, first you have to have a low pass filter to filter the high frequencies. So I had some challenges there. I had to do oversampling and digital filtering before sampling, final sampling. That's just an interesting story.
Super nice project. Many thanks, Istvan. I see there was also a couple of comments from François in the chat, but you can read this then in the chat if you want to stop. Stop sharing. Good. Many thanks. I will stop the recording now. And then, yeah, as I said, so there are a few comments there. Maybe you can continue the discussion there in the chat, and then I will invite Dave and Ken. I don't know who wants to start sharing there. Rotor Rampage. So we started with a game, we end with a game.
Yeah, we can do that.
Perfect. Let me just start the recording.
You see okay there, can you?
Yes, it's okay. Now you can start.
Okay, so then we'll just start here. So just a little bit of background, same as everybody else. Grew up with a 64 VIC-20, used a pad at school, and really wanted to write a game now of sort of semi-retired. So I wrote Puckman last year, redefined the pet character set, made a charge N for it, and you can see in here it's a bit flaky as an early version, but it did the job. A few people sort of downloaded it, got the ROM, and had their own go at it. But I was limited by the memory in a pet, so loading from disk was quite important. And I spent a year trying to figure out how to load from disk. Read all the forums, all the documentation, just couldn't figure it out. And then I got a message from Ken, who knew how to do that. And he's very, very good at 6502 assembly. So what we did is we both started to work on building this project. My side was more from prototyping, from game design, and then eventually converting it all across into assembler. And Ken can go into a bit more detail about how we did all that. But we ended up basically building, let's see if I've got a document here we can show you. We were doing some collaboration, and we actually ended up with this huge document about how the game was going to work, all the features in the game, all the technical details about how it worked in the memory, how the maps were laid out, what graphics we could use, what we couldn't use. And using collaboration in here, we both generated a list of parts that we were going to work on, parts that issues and problems that were occurring, mapping the memory out, building the levels, and eventually, after several months' hard work, we came up with Rotor Rampage. And we're just going to show you a quick look at the game. It uses disk. It's the only way we could get it to get as much information that we wanted in. And let's start it up here. So just going to switch something on here to make this easier to look at. So we decided that it's going to be a helicopter game. It was there were some games on the 64 that you probably remember that started with helicopters, and then feature creep came in. So every time there was like another idea, let's add gravity into it. So if we go up here and we shoot the wall, you know, we wanted destructible scenery, and then we needed to decide how the game was going to work. So we decided that you needed to have a certain amount of fuel and a certain amount of ammo to complete the game. Aliens, when they hit you, would drain your fuel down, so you had to kill them quickly. So this is how it really started, and I'll just run through a few parts of the map here. So you can actually shoot out the blocks here to get through this wall, and the idea is to collect these people en route. If I can get down there. And you've got aliens that are after you all the time, and you've got arrows shooting at you, and you've got to shoot those. You've got to be very careful not to actually shoot the people as well. Just fly over them to pick them up. They will walk around to try and get away. You have to shoot through certain walls to get to places. You'll also find that, the aliens are a little bit more angry than they used to be. So I'll try and get past that one. So everything is loaded from a SD card or a floppy disk. It will actually work on a floppy disk drive. The level itself is, we went for a 16K chunk of memory. It means that it's very quick to move it in, move it out, and build the animation on top of it. We're not having to load large tiles up and work out where they are and plot them all. So it's really giving the interface a nice slick feel to it. You'll see some of the other feature creeps that came in here. In fact, some of the levels, you'll see the word feature creep on it. That's a joke between me and Ken. But at the last minute, I said, well, it'd be a great idea if we could have, running lava in the game. So if I show you there, shot a hole in the wall now, and the lava's going to pour out all over the place. And it got to more and more features we're adding. There are certain hidden places that if you fly over, it will actually trigger a wall to open. We're trying to make it as interesting as possible. And really, we're using pretty much every resource that the pet's got. I think Ken will be able to clarify, but I think after it was put into assembly, there was only a handful of bytes of memory that was actually left in there. Ken really did a great job in assembly. He's built joystick support in there as well. I don't know if I can go back here, show you this. I did a load of work in Golang trying to convert MIDI files into a format that a pet would play. And we've worked together on that. And eventually we've got some good results. So you'll hear when you first load up the game and start playing it, there's some tunes inside there. We're giving this game away free to everybody. The idea, it's more of a retro passion for us to build this. I really want to keep as many pets alive, so I collect pets, I restore them. You know, it's a dwindling resource out there, and some of the parts are getting difficult to find. In fact, 2 parts in particular are impossible to find. So the idea is getting it live again, and we'll build this game, we'll give it out to free. We'll also go across in a minute how we designed the levels inside here as well. So again, the objective is, you know, you can pick up hearts for memory there, pick up ammo, refuel. I'm just going to get one of these. And on every map in the bottom right corner, there's a little exit that you have to fly over. And there's some cheeky little things like that. You know, you pick up somebody and an arrow's just in the wrong place to get you. So let's just fly around quickly and see if we can get some other areas. So another feature creep was, oops, that's something that happens all the time. So you've got to be really careful or you'll assassinate the people that you're supposed to be rescuing. There are actually bombs that you can pick up. So I'll show you hidden room at the moment. So if we come down here, you'll see that, let's just shoot these aliens. Oh, nearly killed up. Oh, got hit by an arrow there. I've actually got it in cheat mode at the moment. That's why I didn't die then. You'll see when you die, your helicopter breaks into pieces and falls to the ground. But you can see there's some money in there we've got to get to. We can't get through the granite rock behind here, but if you know where the secret exits are and you find them when you fly over them, you can see that opened up the wall. So that enables us to fly into there and pick up all the extra loot and all the extra cash. And it's got to the point where Ken's going to have to change some of the code to put larger scores in the top right-hand corner to take them all into account, because the scores are getting quite big now. So 16K for the map gives us quite a large environment that we can fly around, and all the animations are done on that. You can see I've tried to exit the map there and I haven't rescued everybody, so it won't let me. Each map is loaded up directly from the disk. I can cycle through them here, so we can load up the next one here. Got a picture of the old floppy drive there. And you can see there, each one's a little bit more challenging and a little bit more difficult, and some extra features in them. I think if we cycle through a couple of them in here, there's 10 levels in total. You know, we've got some Egyptian tombs in this one here. Let's go along to the next one. A couple of standard ones in here. And then we're going to a sort of medieval kind of map inside here. You've got the bombs as well, so if I can drop a few bombs in here, and you can see you can sort of break through into other caverns and stuff. I'm not sure whether you're picking up the sound effects in the shared window here, but there is sound effects and music in the game as well. So let's just cycle across a few other screens here. So the objective was in here, I think, when we started building this, was to make it as complicated as possible and to give Ken as much work as I could and use up as much memory to get as many features in the game. So this is a Dyson sphere level. We can just cycle through and maybe have a look at one or two more just quickly. As you go through, the levels get more complicated, as I said, but the graphics will change inside here. So you can see this one's completely different kind of style. Again, another hidden platform. If you land the helicopter there, it opens up the wall here. So you can get through and then into the level. This one's actually based on the Commodore PET motherboard. So as you fly through here, and we'll open up some doors in here, get rid of these aliens. You'll see that there's a 6502 chip in here, but as you fly around, you'll find components that exist in the PET. Actually, if I just break through here, you'll probably be able to see. Let's get through here. Some Jack Trammell's quotes that are in here. Yeah, we're going to get in trouble with this. We're going to end up spending the whole time just watching me play the game here. But yeah, you can see down here. There we go. Some quotes from Jack Trammell. So that's a quick look at the game. Joystick support is in there now. We've also done quite a few other levels that are going to be coming out in level packs. You'll see on the left-hand side here that Ken, again, Assembler Excellent here, has managed to get this working on a 8032 and 80 column mode. And even though it's moving a lot more data around, the game is still smooth and as playable as it is on the standard pets. So I think you have to have a 32K pet to run this. Apart from that, we've got it working all the way down to ROM level 2. So if you're running a pet with one of these RAM-ROM boards, you can run it on pretty much anything that's out there. So again, minimum level of that. So on top of that, we've designed and built, that's the website if you want to go and have a look. All the downloads in there are just one-click downloads. If you've got an early pet, which has a very old version of the kernels, there is a version there for it now to get you up and running on that one. And to have a quick look, and this is something we're going to be releasing, is the level editor. So this is written partly in Golang and partly in a product called Zojo, funny enough, which is a good rapid development environment. There are quite a few algorithms for generating game levels and maps and things like that, and there's a couple of implemented in here. We can go through those at probably some other point, and we can put all the instructions will be in the documents that come with this. But basically, top left-hand corner here, I've actually decoded the actual ROM character set for the Commodore PET and rendered it in a bitmap here. So if you want to build a map here, you can actually pick components. So, you know, we can draw a square here. In fact, let's just clear the map here. So I could draw an area like this, and there's fill routines and everything like an art package in here for game design. You can just click on what you want. It has some quite nice features up here where you can say I want to smooth it, and you can see it's actually doubled the pixel level around the objects that are inside here. There are hotkeys that you can use for putting fuel bases in, and if you want to put people in, get that in the right place. So it's completely automated. We're just working on cut, paste, and zoom and all that kind of stuff inside here. And it's as easy really as just clicking on the level that you want to edit. You can scroll around within that level, so you can get an idea here, if I can zoom out slightly, of the size of the level. So each one of these dark lines around here is actually a 40 by 25 screen. So you can see this, I think it's 16 screens that make up one level. And they're loaded fairly quick, so it doesn't interrupt gameplay. And yeah, I think this is going to be really interesting when people start playing around with this and building their own maps. We're already talking about you know, the ports to other platforms in this. I think what's really cool about this is the game engine that Ken's built inside this, because it can be modified and tweaked really for a whole range of different types of games. If you wanted to write Defender in this, it would only be a slight modification. In fact, you could probably do it just by using top part of one level. You've got the aliens, you've got the scrolling and the detection and everything inside there. So there's some really cool bits and pieces in here. I think Ken's probably going to give you a better overview of how he achieved this and what the compiler was and everything that he used. But yeah, I mean, that's you know, a really quick overview of Rotor Rampage. It came out of me spending a lot of time trying to figure out how to read and write from the disk drive, because I knew that there wasn't enough memory in the PET really to get the kind of level of detail and the amount of levels that were required to do a decent game. And then the fortunate meeting Ken on one of the forums when with an answer to my prayers basically, and managing to build that low-level code to get us to have all this extra level of detail. So there are 3 packages on the website. We've got the standard 40-column PET, so that's your 4032s. We've got the 80-column PET and the early, you know, the Microsoft cookie one, if you like, the one that Bill Gates put his own company name into, which he shouldn't have done, all the way back to the 2001N. And if you're lucky enough to have one of the earlier PETs, the blue screen PETs, then as long as you get a RAM-ROM board so that you can get the at least basic 2 running on it with 32K, you can run it on one of those as well. So I think I've summarized as quick as I can. I'll hand over to Ken now, who's technical architect in the back of all of this, and he can give you a bit of background on the compiler that he's used and how he managed to squeeze so much into such a small space of memory. Great.
All right. Well, thanks, Dave. I appreciate it. I didn't prepare any fancy graphics, so you can just leave that up there for the moment.
Okay. Okay. Cool.
I just wanted to give a quick little bit of background on how it all came together there. The project actually started as Dave was talking, and I put a few little things together for him, and I started using the CC65 compiler package. A really nice package with lots of features and very easy to use. And after I did a few things for him, I said, "Oh, this is kind of fun." And then I found out how to connect it up with Vice, because Vice has a built-in system monitor as well. So I could do a little bit of hacking on one side, bring it right into Vice, and do the debugging over there. So it all came together quite easily to start there. So that was what kind of got me started. And Dave said, "Well, there's one more thing and one more thing," and he's the feature creep expert there, I'll tell you. One thing led to another, and we ended up. I said, "If I'm going to do this, I'm just going to develop an engine, and you can put whatever you want in it." I wasn't really interested in building the whole game and everything else, but I mean, after a couple 100 hours that we must put into this here, it just kind of took off. The engine itself basically does what Dave was saying. It's got a large size map, and a window of that map is displayed on the screen, and everything is adjustable inside the engine. So that's what Dave was talking about when he said we could do other games with it. It's well suited to bring in a different size map and a different size viewport on the screen, and all the stuff outside that is what is the game unique stuff. So when you see the titles and the scores and all that stuff, that's not part of the actual engine. Everything in the window box that is displayed there is what the engine is doing and where the gameplay actually happens. So the idea behind what I was trying to design was something that we could use and implement in many more games in the future. I haven't decided whether we're going to make that publicly available or not for other people to do their thing, but it's ended up being a nice little package. And by the time I put everything together, I think on the 8032 version, I ended up with 12 bytes left. So by the time we did the music part of it, the map part of it, and the engine actually isn't that big, but it's all the data that it has to deal with. It actually does Z buffering. So everything that's playing in the game actually happens in the game space in the map area, and the viewport function actually just displays a certain map area on your screen. So it kind of made the graphics a lot smoother by doing that. You don't see things jerking and moving around. There are some little tweaks that are put in there specifically for this game, but in general, the engine itself is very adaptable to any number of other things. And we'll probably, in the not too distant future, put out a couple more things similarly coded. So, like I said, many hours went into this, and I tried to keep the flexibility and the options open for a lot of other things. There's actually a few features in there that are in the engine that aren't implemented in this particular game. You may see some more fancy things popping up in the future too. It's a lot of fun, and it was done as a retirement project because I'm retired as well. Wanted something to occupy my time over the winter here, so getting back into the pet end of things, I was a pet service or Commodore service guy for 10 or 15 years back in my earlier youth when these things were rampant, and then out off onto another career. And when I retired from that career, I kind of got back into the Commodore stuff. So this was all part and parcel of many years of learning and going and doing. And I guess in my on my side of things, it was just supposed to be a little bit a fun project. It's all good. We came up with a pretty good product by the time all was. Any questions or comments, or back to you there, Dave?
Many thanks, Dave and Ken. I see a comment from William. Much respect for approaching the development of the game as an engine. And then I saw a comment on Facebook as well that says that looks really cool, and that's from Sven, who's a regular speaker here at our meetings.
One question from me. I never seen a pet, but I have a Commodore 610. Is it working on that one too?
The version we have is very pet specific, unfortunately. We're looking at developing for other platforms, but haven't really embarked on anything quite yet.
Okay.
I think the 610 is quite radically different to how the original PET was architected. So I think that would be quite a difficult one to, well, time-consuming one to do. And I think you're lucky to have one because there are very, very few of those around compared to pets, and there are not many pets either. So yeah, it's more and more the obscure platform down the road.
I was surprised really how fast and how smooth is the scrolling. Is it because you're on the on the emulator, or do you have the same?
No, that's the actual speed of the game playing. It's coded completely in machine language. There's no basic parts or anything else. We do use some of the ROM calls for the disk loading and stuff like that, but basically that was kind of one of my criteria. I think we ended up, I calculated about 12 frames per second. And for a pet, that's pretty amazing, actually.
Yeah, and more importantly,
it's actually happening.
Yeah, the no flickering, because it's effectively double buffered, isn't it, from reading from the map? So, yeah, that was. I mean, you do see flickering in the game, but that's by design. You know, we wanted the rotors. In fact, that was a great idea of Ken's there to make the rotors flicker like that, make it looks like. Yeah,
it's actually a little bit smoother when you get on the actual pet. It's a little bit smoother. It's because it looks a little choppy. Yeah, it looks a little choppy because of the sharing screen in the video and all that stuff. Even on Dice, it's actually pretty smooth.
So, and then I would like to come back to this level editor that you have made. In practice, how does it work? So let's say I go and I get a copy of the game, and then I have the copy editor. How in practice, how does that work, that I can integrate and play on my own level?
Okay, so it is as simple as naming the file. The engine will look for level 00, 01, 02, 03 all the way through, and it will keep going on until it finds until it runs out. So you basically, you come into here, you say, you know, I want to create a new map. You design your new map. You save it as a level number, and that file is a data file that you can just copy straight to an SD card and put on in the game directory and put it on your pet straight away. And then obviously you can, from your SD card, you can load it and then save it out to a real floppy drive if you wanted to get the full experience on there. It's there's a little bit of work, but there's we could probably get a cassette version going. There'll be some of the screens that you'd have to skip. You know, we couldn't load the instructions. The instructions actually are a level themselves. They're level 99, I think, in here. So you can see, you know, there are quite some detailed instructions in here of all the different features in here. I don't know if we missed any. Oh, one of the interesting things that we were doing inside here was actually trying to get the game working so that you could hold two keys down at the same time. And I had some old assembler from somewhere that actually gave us the ability to hold multiple keys down, so you can fly, you know, press 8 and 6 and fly upright. Although there are the extra diagonal keys in there as well now, but there was some interesting other little bits and pieces to go in there as well. But yeah, it really is just a set of 160,000 blocks. When you actually pick a character in your palette over here, you can see if I click on the letter A in verse, you'll see it's gives us the hex and the other number for it. And then you can just basically, in fact, if I just go into here and clear the map, if you say, for example, you wanted to, you know, you had some ground here, for example, you could use. We found there's actually two special characters that you don't really see on a pet. You have the normal 160 block, but you also have this in shifted block, and you'll see this is a different color at the moment just from the game editor. And you have the same with the space. You have a normal 32 space up here, and if we come down to here, there is another space, 96. And when you're designing the game, you can actually put this in anywhere on the map. And as the aircraft flies over or through this space, or even shoots this space, it will make these blocks disappear. So you can have basically hidden rooms or walls that you can't get through unless you've triggered some magic process in the way. But the way the map designer works is if you hit a character, for example, the letter A here, and click it onto the map, it actually reads every single byte from the character ROM chip that it loads. It actually loads in the raw character ROM chip from the PET. And then it renders it bit by bit into that square, and then it renders the whole 160 blocks using raster lines. You can still move around fairly quickly inside it, which is nice. But that's how it builds up. There is a definite file definition that we have for our levels, which include music. It includes what we call an alien table that has all the locations in the map of where the aliens are, and they're all embedded together, and they sort of sit just before the map data, and then the game engine loads in, and it loads in each map. Each map's got its own music. Each map's got its own set of aliens. And one thing you don't see in the game, at the moment, the aliens all look the same, but the engine supports the ability to have different size and different animations for the aliens, and different different pictures for the aircraft as well. So there's a lot of extra cool stuff that's hidden away inside there.
Super nice indeed. Yes, I can imagine that maybe you can have very soon a huge community of people developing extra levels, and
Yeah, that's the dream. In fact, one quick thing as well, if we've got time, is that we've been working on looking at a online version of this. So there is a ROM board that you can get from the States that has Wi-Fi built into it. We've been looking at the protocol behind that to see whether we can actually have it uniquely identify every pet that's out there. You can store your high score tables up there. There is something in high scores in here we haven't got time to go into, but yeah, actually building that into an online thing, so you can go in and you can see all the map that people have built. You go down and pick whatever map you want to play, and eventually, hopefully, having loads of games listed in there as well that you can sort of pull down, etc.
It would be super nice. I see a question from William. I think you answered that, but let's see. What language development environment was used to build the editor?
There's parts of Golang in here, which is Google's internal development language. The UI is done in a project called Zojo. In fact, if you like kind of, I would say it's like basic type of language, but it's more structured than that. It is a really good prototyping language. You can build things very, very fast in it, and it uses the LLVM compiler, so it does compile to a pretty quick executable. I've built encrypted phones using it, so it is quite a capable engine.
Good. Any other questions? Anybody?
Oh, just one thing. This will be available on Linux and Mac as well. The compiler compiles to those endpoints.
Nice. I don't have any more questions. If no more questions, then I will stop the recording now. Many, many thanks, Dave and Ken.
Okay.
And yeah, and then that leaves us. That brings us to the end then of the meeting today. Many, many thanks, everyone. All the of course the attendees, but of course the speaker as well. I say it. I think every time, if no speakers, then there is no event, of course. So as of yes, immediately, I think the event itself is available on Facebook to replay the whole thing, but the recordings will be added in the coming days, probably next weekend on our YouTube channel. So many thanks again. The next meeting will be in June, one per quarter, as I said at the beginning of the call. So don't hesitate to submit your proposals as of today, actually, either by contacting me through Facebook or the website. There is a form where you can submit things. And yeah, many thanks again. Have a good evening, afternoon, wherever you are, and see you next time then.
All right. Thanks a lot.
Thank you.
Thank you.
Bye now.
Thank you. Goodbye, everyone.